So the next law to cover is something known as Dalton's law of partial pressures, and it has a lot of sort of interesting applications. Let me explain to you, though, what a partial pressure is, right? A partial pressure is part of a total. So let's say you have 1 atmosphere pressure, right? And 1/4 of that pressure, 0.25 atmospheres, was oxygen, right? So that's 0.25 is part of the total of 1 atmosphere. So that's oxygen's partial pressure. A lot of times people think it's something really strange and different. It's just the part that that gas occupies. So this idea was originally brought up by John Dalton, the same guy as atomic theory. And back in the day, it wasn't obvious that if you took 1 atmosphere of one gas and 1 atmosphere of another gas and you mixed them together, it would be 2 atmospheres. Like, to us, maybe that sort of just makes sense, right? You would expect that, but they didn't have a good reason to know that that would be true. Sort of give you kind of a weird reason why things like that weren't necessarily thought to be true, is if I took water, right, and I took 50 mils of water, and I took 50 mils of pure ethyl alcohol, and I put it in the water, so I made a solution, right? Most people would say, well, that'll be 100 milliliters. Well, it turns out it's only like 85 milliliters. And the reason for that is there are very strong intermolecular forces between water and alcohol. And literally, when you mix the two together, they become more dense. They pull in closer to each other, and so the volume decreases. Now, we know that gases don't have intermolecular forces, and because they don't have intermolecular forces, they mix in a rational way. You don't expect to take two volumes of gases and mix them together and then have a volume that's completely unrelated. But that's actually true for liquids. Any two liquids you mix, you never quite know whether or not the volume is going to be smaller or larger, so it could go either way. Now, anyways. So Dalton's law of partial pressure is pretty straightforward. It says, here's an example of how you would do it, right? It says, if a container has 0.22 atmospheres of oxygen, 0.63 atmospheres of nitrogen, and 0.06 atmospheres of helium, what is the total pressure, right? So P total is equal to P of the oxygen plus P of the nitrogen plus P of the helium. You really just add the numbers together. So this will come out to be, let's go ahead and just pull a calculator for fun, because I don't really remember what the answer is. It's going to be 0.22 plus 0.63 plus 0.06. So the total pressure, you expect it to be 0.91 atmospheres. Now, the partial pressure of oxygen is 0.22 atmospheres. The partial pressure of helium is 0.06 atmospheres, etc. To know the partial pressure, you just read what its pressure is. Now let's say I changed the amount of helium, right? And I wanted to know what the partial pressure of oxygen was. So let's say the total pressure is 0.91 atmospheres. And then the partial pressure of helium is 0.31 atmospheres. What are the pressures of oxygen and nitrogen combined? Okay, so this is the kind of question you might expect to see on a test for partial pressures, right? I know the total pressure is 0.91. So I know P total, right, is 0.91. That's going to be equal to the pressure of oxygen plus the pressure of nitrogen plus the pressure of the helium again, it's the same equation, but that's going to be 0.31 atmospheres. So if I want to calculate the pressure of oxygen and nitrogen combined, I subtract 0.31 from 0.91. So the pressure, let me just write this down here, the pressure of O2 plus the pressure of N2 is equal to 0.91 minus the pressure of helium, 0.31, or 0.60 atm, like that. So you just subtract. When you need to know the pressure of a couple gases or one gas, you just subtract everything you know from the total, and that'll give you the pressure of the gas. Okay, so before I talk about Henry's law, I want to say one other thing about Dalton's law of partial pressures. You know, when you hear that term that says, oh, air is 21% oxygen, right? That's actually related to the partial pressure of oxygen in the air. And in other words, if you want to know, 21% means 21% of the atmosphere is oxygen. So if let's say your atmospheric pressure, let's say P of the atmosphere, let's say it's 750 millimeters of mercury, like that, then the partial pressure of oxygen is 21% of that. So 21 over 100, like that. And so you can calculate that out as 750 times 21 divided by 100. So the partial pressure of oxygen is about 158 millimeters of mercury. Okay, so that's normal air. So now, so you have that oxygen in your lungs as you breathe, and so your body absorbs the oxygen, right? And that's what creates your 100%, or your typically above 90% saturation of oxygen in your blood. This value right here is important in establishing how much oxygen will be in your blood, and that's related to this other law that's here. Let me get rid of some of this. That's called Henry's law. So Henry's law says this: the solubility of gas is proportional to the partial pressure of the gas above the solution. So let's say your blood saturation is 100%, okay, which is good, at 158 millimeters of mercury. What happens if it goes up to, let's say, 200 millimeters of mercury, right? Well, now all of a sudden you have more oxygen in your blood. Where this kind of technique can get used is in a ventilator, for example. If you're not getting enough oxygen, they can supplement the air with oxygen, and so they're increasing the partial pressure of the oxygen, so you get higher blood concentration of oxygen in your body. Now, there's a device called a respirator, and it's very similar in sort of intent to a ventilator. But a respirator can do a bunch of things. So if you're working on a job site, for example, and you have to go work in a tanker, and that inside of that tanker has poor oxygen levels, you'll put a respirator on, and that respirator purifies the air, but it can also increase the oxygen content of the air that you're breathing, so that you get closer to the 158 millimeters of mercury. Other places respirators get used is when you go to high elevation. If you go to really high elevation, what happens is the atmospheric pressure decreases, and when the total pressure decreases, right, that's part of this equation here. This is your total pressure. If your total pressure decreases, then this number will decrease as well. And as a result, you can be oxygen deficient above about 18,000 feet, which, like when people are climbing up to Everest and all that kind of stuff, that's when people sort of pass out and die. Okay. But you can use a respirator. You can put that on, and what it'll do is it'll supplement the oxygen of the air that you're breathing, so that the partial pressure of oxygen is higher than the surrounding atmosphere. So those are some interesting ideas about Henry's law. The partial pressure of a gas determines its solubility in solution. In this case, the partial pressure of oxygen, the solution is your blood, determines the amount of oxygen that's in your blood. Okay? Now, Basically, it's a simple proportionality again. If you increase the oxygen partial pressure, right, then the concentration of oxygen in the solution will increase proportionally. So if you double it, then you're going to double the concentration of oxygen that's in your blood, for example, which would actually be a bad thing. You don't really want to double because too much oxygen will kill you too. All right, so yeah, so basically, solubility of gas in a solution is proportional to the partial pressure of a gas above the solution. Higher partial pressure means higher solubility, which means more of the gas in the solution. An interesting kind of fun example is a soda. I don't know if you ever played with sodas when you were a kid, but you know how when you just crack it open and all of a sudden all these bubbles come out? So if you go inside the lid of a soda bottle right before you open it. So this is an actual old-fashioned bottle, I guess. I guess I'm old-fashioned. You have a bottle that looks like this. Maybe it's a beer bottle. And then you pop the cap off like that, right? What happens? Well, inside here, if it's a soda, it's about 2 atmospheres of pressure that's in there. So what ends up happening when you pop that off, right, all of a sudden the solubility of the gas in solution, it goes way down, and that's where the bubbles come out. The bubbles is literally carbon dioxide bubbling out of the solution because its solubility has decreased. All right, so I talked about the oxygen, blood, and respirators and ventilators. They're 2 slightly different things. A respirator is like a job site thing where you'd wear it and go inside oxygen poor environments or go to high altitude. The ventilator is the one where they intubate patients, and then it controls oxygen concentrations by adjusting the partial pressure of oxygen, and it also helps the patients breathe. It's mechanical, so it actually forces the breathing. And there's other ways that people increase blood oxygen concentration. There's something called a hyperbaric chamber. Or a hyperoxic chamber. So you know hypoxia, if you've heard that term, that means low oxygen. Hyperoxia means high oxygen. So you can actually put somebody in a chamber and increase the atmospheric pressure because your total pressure goes up. The amount of oxygen you absorb goes up. So you have to be a little bit careful. You can't just go crazy because you get too much oxygen. That's not good. And they've been doing a lot of research on that, looking at treatments for some sort of muscular issues like muscular dystrophy and things like that, getting more oxygen to the nerves.